Hello everybody! This video is going to teach you about the best method for solving a system of linear equations. Now, that being said, I don't think there is a best method. There's certain things that make sense to use one way versus the other. Well, I'll explain that. First of all, when it comes to graphing, I don't use graphing. You may want to if you like to graph, but I think it's kind of a pain. Put it into y equals mx plus b, then get out graph paper, see where they cross, and hopefully you graph it correctly. That's just, not a method I prefer. However, I do use my rules for graphing in that y equals mx plus b and what I know about equations to help me sometimes. So for example, if I look at these two equations here, the first set, you look here, they have the same slope. And then if you also look, they have a different intercept. Well, what does that tell you? If it has the same slope, different intercept, means that they're parallel and there's no solution. So something like that, that's how I would use the graphing. So I don't actually graph it, but I just use what I know about graphing to help me solve some of these. This next one, if you look at it, this one also has the same slope. And then if I solve this for y, if I subtracted y from both sides, you would see that this would become a -5, which means that those two equations are exactly the same. They'd be on top of each other, and the answer would be infinity, or an infinite number of solutions. So that's how I use graphing. Beyond that, I don't really use it. Let's talk about substitution. Substitution is pretty good, but can also lead to some ugly problems. What I do is I look at equations, and when I see that one of the variables, here we have two of the variables, have a coefficient of 1. You come over here, this has a coefficient of 1. Right away, that tells me, you know what, this is a good candidate for substitution. For this first problem, when I look at this, they both say y equals. So if I took this and I substituted it in for this y, and basically what I'm doing is just setting the two equations equal to each other, like this. And then I could solve for x. Okay? On the other one, over here, on the right-hand side, I have y has a coefficient of 1, so I can easily subtract this, add this 5x to both sides, is -5x. So if I added 5x to both sides, I would have y is equal to 5x minus 2. And now I could take this and I could substitute it in for y and then solve for x. Okay, that's how I would use this. If you see that you have a coefficient of 1 on one of your variables, then it's a great candidate for substitution. Now, elimination is by far the one that most students prefer because they think it's very straightforward and it can always be used. In fact, this is actually my favorite method as well. When it comes to elimination, if you see that the coefficient is the same number or the opposite number. So if it was a +2 and the other one was a -2, or here we have both of them are +2, then that's a great candidate for elimination because what you would do is you just subtract these two equations and then the variable is gone. On this other one over here, when you look at the coefficients, this one has a 14 and this one has a -7. But if I were to take this equation and multiply every term by 2, then I would end up with a 14y over there as well, and then I could use my elimination method. Okay, so that's how to identify a quick way of using elimination. And then you have some problems that are just ugly. All right, when you have an ugly problem, I use the elimination method, and this is why. So let's just say, okay, let's see. These two equations. I'm going to show you each way what it would look like if you did each method. For graphing, if you were to graph these, you need to first get them into y equals mx plus b, okay, which is a lot of work. But here, let me just do it really quickly. 3x minus 2y is equal to 2. Subtract 3, and I have -2y is equal to -3x plus 2. And then I would divide by 2, and I would have y is equal to a 3 over 2x minus 1. Okay, there's one of them. And then I have to do the other one. 5x minus 5y is equal to 10. And I would subtract the 5x first. I have -5y is equal to -5x plus 10. Divide by 5. And I would have y is equal to x plus 2. Okay? Then what I could do is get out graph paper and I can actually graph these two. That was a lot of work though, because I'm assuming you're not going to do them that fast. And then you'd have to graph them and hopefully they happen to cross at a nice point, and I don't know if they always will. So that was a lot of work. And then when you talk about substitution, substitution can be ugly for a different reason. Let me show you. If I took this equation here, okay, yeah, I could do that equation there. And then I'm going to solve for y. I would have y is equal to 3 over 2x minus 1. The problem with this is that when I solve this thing, I'd end up with a fraction that I'd be putting into the equation and substituting. Fractions are kind of ugly. If I solved for x, I would have x is equal to 2/3 y plus 2/3. Now I have even more fractions. Substitution method is ugly. Elimination works great because here I can say, well, look, if I look at these terms here, I can multiply the top equation by 5, the bottom equation by 2, and then I would end up with 10 for my y's. So I could just do this and say, all right, well, this one I'm going to multiply by 5 on both sides in all terms. This one I'm going to multiply by 2. And then what I end up with is 15x minus 10y is equal to 10. And 10x minus 10y is equal to 20. And then the signs are the same. I would subtract the equations. It's much more straightforward. It doesn't put fractions, the solving for y and then graphing where you can make a mistake. So elimination is really the method I prefer. But again, it's your choice. It's whatever you feel most comfortable with and whatever makes the most sense to you. Okay? That is all. Goodbye.